I'm Joanna Simpson here at QuantMinds International in Vienna. Joining me now is Alexei Kondratyev, Managing Director, Head of Data Analytics, Electronic Market Solutions at Standard Chartered Bank. Thank you very much for joining me. What capabilities does quantum computing allow for quantitative finance, which has not been possible to do before?
I would say that quantum computing is very different when we compare it to classical one. In quantum computing, we can do things that we cannot do with classical computing. So, for example, with digital gate model-based quantum computers, we can perform operations that are not possible on classical hardware. For example, we can work on a superposition state where we can effectively perform a lot of calculations in one step, unlike a classical situation where we need to process every single state, memory state independently. And with analog quantum annealing type quantum computing, we can use a quantum mechanical property of quantum tunneling, which is again very powerful and something that we cannot do classically. This gives us capability to solve problems differently in different ways, ways that are not possible on classical hardware. So, for example, we can solve problems that are NP hard on classical computing, but actually quite easy quantumly. One example would be portfolio optimization. Discrete portfolio optimization is an NP hard problem on classical hardware, but on quantum annealing, this is something that we can solve very fast and efficiently. We can also mention here machine learning, another type of problems where quantum computing promises to help us in quant finance space. We can train different machine learning models more efficiently quantumly. And finally, it's all about simulation. Quantum mechanics is probabilistic in nature, and quantum computing lends itself naturally to all kinds of simulation, and we can imagine that risk engines, Monte Carlo risk engines of the future, can potentially be run on quantum hardware.
So which of these applications are you working on at the moment, and how's the research going?
We started our research with a portfolio optimization problem using analog quantum annealer. Now we are trying to move into digital gate model-based quantum hardware and see if we can use it for better training various machine learning models. So I would say that right now we are at the stage where we're experimenting with quantum computing, mainly in machine learning space.
And to what extent will quantum computing reshape quantitative finance in the next 5 years and also the next 50?
I'm a big optimist here. I believe that we are about to witness first real-world production-level applications of quantum computing in finance, definitely in the next 3 to 5 years. Going 50 years into the future, we can probably make a statement that with almost infinite computing power that quantum computers will offer, and also reasonably cheap, maybe very cheap, infinite computing power, we are going to see disruptions of all businesses, all processes, all technologies, and quant finance is just one of them. It's difficult to predict in which way quant finance specifically will be disrupted by this new emerging technology, but we know that once we have access to more computing power and cheaper computing power, we'll find new use cases.
Alexei Kondratyev, thank you very much for your time.
Thank you.